Hello and welcome to the section of the MATLAB tutor. Now in this section we're going to build on what we did just a minute ago, and we're going to calculate derivatives, but what I want to do is show you, a lot of times you'll calculate the derivative of a function and you want to evaluate the derivative at a point. So you'll calculate the derivative and then want to plug in a value and evaluate that derivative at x is equal to 4 or something. Let me show you how you would do that. It's not too hard to figure out on your own, but sometimes it's just easy to see it done. Let's first go ahead and define our x variable as a symbol like we've been doing before, and then let's define some function in line. Let's call it x squared minus 3. Okay, and the independent variable is x. So here is our function, right? So we go ahead and hit enter, and we can of course see a nice pretty definition here. F of x is equal to x squared minus 3. So typically what you would do now is you'd want to take the derivative of f of x, and you'll get a new function. In calculus we learn it's f prime of x, right, which is the derivative. Now we can go ahead and do this. diff f of x comma x, just like we did in the last section, and we go ahead and calculate the derivative. But a lot of times when you calculate that derivative, you want to be able to plug in values into the new function that you get, f prime of x, right? So how do you actually do that? Because now we calculated the derivative, it's on the screen, but how do we define that as a new function that we can then use and plug values into? Well, the easiest way to do it is to also use the inline function again. So let's call the new function derivative. Derivative, right? Pretty descriptive. And we'll set that equal to inline. Inline means create a function. It's saying MATLAB create a function for me. So what is the value of this function? Well, we want to calculate the derivative, so we'll just say diff f of x like this, okay? And the independent variable for this function is x. Actually, I want to do it like this. So what we've done basically, if you look at it carefully, is we've created an inline function, right? That means create a function for me. The value of the function that we're creating is the derivative of this other function we've created, and the independent variable of this new function is also x, and we're labeling it derivative. So when we hit enter, it calculates the derivative, and it says the derivative as a function of x is equal to 2 times x, or x times 2. And if we look up to our original function, x squared minus 3, the derivative is actually 2x, right? Which is what we have. So now I can say derivative evaluated at 3, and I get an answer. Derivative evaluated at -1, and I get an answer. So that's basically how you do it. Let me clear the screen. Let's create a new function. I'll show you something else real quick. If you try to skip steps a little bit and say, let's create a new function g, and we'll say that it's equal to x cubed minus 1, let's say. Like this. So here's a new function that we've created. X is already a symbolic variable, so we don't have to do that again. So g of x is equal to this guy. Now if you're just kind of guessing how to use MATLAB, what you probably would do is you'd say derivative. You would say derivative, or let's create a new variable. Let's call it deriv, is equal to diff g of x like this. You'd probably do something like this. You'd say, okay, well, I'm going to create this new function, and I'm going to set it equal to the derivative of my original function, right? And that does work. It looks like it appears to work. The derivative, the new function that I'm trying to create, is equal to 3x squared, but then when I try to actually use it for something, it doesn't work. Because what you've done is you've created a variable, and you've called this variable deriv, and you've set it equal to 3x squared, but it's not a function. You're not able to plug values into it. It's just an expression equal to 3 times x squared, right? So again, just to refresh and close the loop on how to do this, we've defined a function g of x, okay? And now we would like to calculate its derivative and put it into a new function. Right? So the way we want to do that is we want to say, let's call it deriv this time so we're not colliding with what we've done before, is equal to, inline, that means create a function. It's the derivative of g of x, right, with respect to x. So this is the derivative of the function that we want, and the independent variable of our new function is also x. So that's basically the way you do that. And you get your answer, right? And this is a function that can be evaluated. deriv as a function of 3 or something, put it in there and it works just fine. So when you calculate derivatives, if you want to use that f prime of x in a calculation, you need to create a new function. So here's how you create a new function. You use the inline operator. You tell it what your function is going to be equal to. In this case, it's a derivative. The independent variable of your new function is also x, and it'll create the function in a manner that you can then use it. That happens so much whenever you're calculating derivatives. Maybe you want to plot it. Well, you're going to need to have it in the form like this to be able to do something like that. Or if you want to do some other kind of calculus function on it, you're going to need it defined in terms of a mathematical function. So go and take a look at that, play around with it, make sure you understand it so that you can then use these calculus functions in MATLAB.